Hi guys, welcome to my channel Kriyantrika. Today we will be discussing about linkages and mechanisms. Look around carefully. Almost every moving machine around you, from car engines to robotic arms to bicycle pedals to windshield wipers, works because of linkages and mechanisms. Now what exactly are they? Like a linkage is simply a group of rigid links connected together using joints. When these links move together in a controlled way, they form a mechanism. And mechanisms are what convert one type of motion into another. Now, look at the top left of this image. First, we have joints. Joints connect links together and allow movement. A revolute joint allows rotational motion, like a door hinge. A prismatic joint allows sliding motion, like a piston moving inside a cylinder. Now moving to the center section, a link is rigid body that does not change shape. That is called as link. When two links connect, they form a pair. When two links are connected, they becomes pair. Multiple connected links form a linkage. The linkage happens when multiple links gets connected together. And when one link is fixed to control motion, the entire system becomes a mechanism. When multiple links are connected together and in that one links get fixed means that becomes a mechanism. This is the foundation of machine motion. Now let us understand the most important mechanisms. First, four bar linkage. This this one this is the one of the most common mechanism in engineering. Four rigid bars are connected in a loop. Depending on link lengths, different motion patterns are produced. Used in robotic arms, suspension systems, and windshield wipers. Now look at the second type, slider crank mechanism. This is extremely important because it converts rotational motion into reciprocating motion, or the opposite. This mechanism exists inside every car engine. The crankshaft rotates while the piston moves up and down. Now see now that crankshaft makes differentials, or even wheels make rotation as according to the piston movement up and down. Now see the third types, double slider crank mechanism. This uses two sliding joints and is commonly used in pumps and balanced motion systems. Now the fourth type, Scotch yoke mechanism. Scotch yoke mechanism is the mechanism which converts rotary motion into perfectly smooth reciprocating motion. Rotary to reciprocating in a smooth manner. Used in shaping machines and actuators. Used in shaping machine and pneumatic actuators. Now look at the fifth type, quick return mechanism. In this mechanism, the return stroke becomes faster than the forward stroke. Very useful in shaper machines and cutting tools. Machines save the time using this clever mechanism. Now, one of the most fascinating system is the sixth one, that is Geneva mechanism. This mechanism converts continuous rotation into intermittent motions. Instead of moving continuously, the output rotates step by step. Used in indexing systems, packaging machines, and mechanical watches. Mechanical watches are nothing but giving auto key to the crown, and it works for like 2 to 3 days or even for a week. Now look at the real life examples below. Windshield wipers, engine pistons, bicycle pedals, sieving machines, robotic arms all use linkage systems. This is why mechanisms are called the language of machine motion. The mechanisms are called the language of motion of the machines. Now let us understand something very important. Mechanisms do not create energy. Mechanisms do not create energy, they control motion intelligently. Just like gears, they control motions intelligently. They decide like how something moves, how fast it moves, and in what direction it moves. And this is exactly what mechanical engineers do. They design motion itself. Mechanical engineers design motion itself. Now look at the degree of freedom section in the corner. This tells us how many independent movements a mechanism can perform. This degrees of freedom tells us that how many independent movements a mechanism can perform. Some mechanisms move in when only one controlled way, others have multiple complex motions. This becomes extremely important in robotics, automation, and industrial machines. And this is why linkages and mechanisms are considered one of the core foundations of mechanical engineering, because every machine is ultimately a carefully controlled motion system. I will come again, because linkages are very important, because every machine is ultimately a carefully controlled machine motion system. Thank you guys.